Hey guys, Dave and Anokin here from Mozaik. So we're here today to do a little bit of an overview of how to run flip sheet machining or flip side nesting in Mozaik, but also go through some like shaker door examples, just the common things that you might need to think about if you're considering cutting doors or doing anything that requires flipping the sheet over in Mozaik. So we're going to go through a bit of an overview of different steps, starting with making sure that the surface you're working on is nice and level. So we've got a spoilboard here that needs to be skimmed, needs to have the skimming surface run to clean it up because we've got some indentations from the prior sheets that have been cut. So we're going to run a skim first, get that nice and level. And then we're going to go through a bit of a process of explaining how to test if your machine is ready to do flip side machining. What I mean by that is making sure that the overall pins of the machine, like where you push your sheets up against, are square and true to the actual drill bits and the router bit on your machine. I'll take some footage there to explain that a little bit better, but what we want to do is make sure that if you drilled a hole 100 millimeters in from the pins in X and Y, and you cut a square out, they're going to be perfectly aligned to those pins. So we'll go through that. We'll also go through the process of how to set up a flip sheet job in Mozaik correctly. So things like measuring out your sheets before you cut them, understanding how to use a trim cut or a squaring cut, and what the difference between the two is and when that applies throughout the process. We'll also go through just running a test door, because obviously we're going to do shaker doors for the first time and we've just thrown some tools in the machine. We want to make sure that they're nice and aligned as well. That way, you know, you're not just diving in and cutting a job and wasting a few sheets of material.
Not a great experience, no.
Exactly. So they're all the things that we're trying to avoid. And this video really is meant to be a bit of a help guide. So if you're just starting to explore one of these areas yourself, you could watch this and really get a step-by-step process. So let's get into skimming the sheet to start with.
Hey guys, so today in the first step, right, we're going to work on the skimming process. So it's very important to ensure that remember that most actual CNCs have their own skimming program. And it's helpful in that sense purely because as you're using the native software, it actually will update the spoilboard thickness for you. Now, there is a program in Mozaik that allows you to do skimming. However, in that process, you also have to do that, then also manually update the thickness on your board to ensure that every time you're using it for future, that is consistently knowing that it is what the thickness is. So for myself, the first thing I'm going to do, working off this CNC, is that I'm going to quickly change the thickness of the spoilboard to ensure that it goes down the increment that I need to be to ensure that all previous operations are actually cleared out.
Yeah, so as you can see here, we've got the jig thickness at 17.2. So we're going to take about 0.3 of a millimeter off, as our cutout tool typically goes down by about 0.2 to 0.25 through the material. So the goal is to make sure we're clearing that off when we're surfacing or skimming the spoilboard. So we're going to set that to 16.9 and then we'll jump back into automatic mode and we'll call up our skimming program. Okay, so what we have now is a much smoother surface. It's removed the vast majority of those indentations. I can still see, you know, there's a deeper section out here towards the edges where we've still got a little bit of an indentation there. Depending on, I guess, you know, your sheet and what you're doing, you may want to just keep skimming that down to remove all of that. But I'd say in our situation for this tutorial, that is probably good enough. It's pretty much flat everywhere else, which is great. So we'll move on to the next stage and we'll start looking at our alignment test and go from there. Okay, so before we explain how to run an alignment test, I want to explain the reason for doing it in the first place. So as we can see here, this is our 10mm compression, right? So this is our 10 comp cutter. And this is like the center of our spindle, of our router bit. And as you can see, there's a distance over here between the drills and the router. So first of all, because there's a physical difference between where the two are located, that means that there's a variable somewhere in your CNC machine where that distance is entered. So that's one area where like a flip sheet can be wrong to begin with. It's just that the router bit is not perfectly aligned with the setting and your global origins to the drills. So what happens when these machines typically get set up at the start is someone takes a measurement and they figure out, okay, from the center here to the center here, if I eyeball that, it's going to be around about 230 millimeters, something like that, right? And then you're going to go, okay, from here back to wherever the reference of my drills are in the other axis, in the x-axis in this case, it's going to be around about 150 kilometers, right? So there's a difference there. And that variable, those distances are stored on your machine in what's called a global origin table. So what we want to do is run a physical test. That way we can check if that variable on your machine is 100% accurate. We want to know if that when you route a square and drill a hole, are they in alignment to each other? That's step one. And then step two is understanding that is the router bit and the drill, both of those, once we have them in alignment, are they square and true and in alignment to the actual pins of the machine? So the physical resting point of this machine, the true zero of where this is sitting, is not the corner of your pins. It's not where the pins are. So, or the stops, whatever you want to call them, right? The pop-up pins on the machine are your reference points, whether it's a pin or a bar or whatever it is on your machine. What you want to make sure is that this ends up being dead accurate to those references. Now, what I commonly see in the way that machines get set up is the machine operator will jog this over to the corner of the sheet or the pins where the spool body is set up, and then they'll zero it off that. Okay, and they'll say, yep, that looks pretty close. And, you know, it's going to be within accuracy of like maybe a millimeter or two. But herein lies the problem, is that it's not dead accurate. So what I mean by that is that you're not going to pick up on it when you run a normal program, right? Because when you run an normal program, you've got whatever your width trim and your length trim in Mozaik are set to. And those trims are typically like 5 millimeters in a metric sense, or maybe they're like, you know, set to an 8 or something like that in imperial sense. And that gives you a fair degree of like freedom, right? Because as long as you're within that tolerance, then you never know that your router bit is not true to the pins, because that tolerance is making up for the difference. Whereas when you're doing a flip sheet, it compounds. You know, if you're out by a millimeter and you flip a sheet over, you're out by 2 millimeters. So the whole idea of what I'm explaining here right now is understanding the physical reason for the variance, and then understanding what you can do about it, how you can test for it, and then how you can go from there. So let's cut to now having a look at the reference pins. We'll run an alignment test and we'll see if this machine's dialed in. All right, so let's look at this piece of material. I'm going to just move it in against these stops. So I'm hitting the two stops here on the x-axis, and on the y-axis, I'm hitting one reference point here. So I know that this piece is like, you know, referenced correctly against the pins, but what I don't know is if the router bit understands that where this corner meets is exactly 0, 0. And that's what we're trying to prove by running a reference or an alignment test, right? Because what we want to do here is say, let's come in a nominated figure away from these two edges. Let's say we come in, I'm gonna speak in metric, right? But let's say we come in 50 millimeters in from the edges, and I'm gonna route 100 millimeter square. And then I'm gonna drill a hole right in the middle of that square. That's gonna tell me a few things, right? If I'm 50 millimeters in and then I'm running 100 millimeter square, I'm gonna drill my hole 100 in off this edge and 100 in off that edge. I mean, you can do this in inches, you can go like 4 inches and then, you know, 2 inches off the sides, totally up to you. But you need just a defined measurement that you can accurately check. So what I want to do here is drill that hole 100 millimeters in from the edge. And I'm going to measure exactly off this point, exactly off that point. Am I 100 millimeters in? And then I'm going to check the route and say, is the hole actually in the center of the route? And that's going to tell me if everything's in alignment. And I'm also going to check, is that route exactly the right distance in off this edge and in off this edge. And if there's any variance in any of that, it's going to tell me that, either the x-axis or the y-axis needs adjustment in the global origins of the machine. If it's correct, then I know I'm set up and ready to go for flip sheet machining and don't need to make any more setup alignment adjustments. So let's go ahead and I'll show you in Mozaik now just how to program that simple test. We'll run it. We'll see how we go. All right, so what we're going to do here is just create the alignment test. So we're going to jump into the optimizer, and with the optimizer, let's just go ahead and create a new job. Let's just give this a name and call this alignment, and then let's just go ahead and select the material. I've got 18 mil material on the machine here, so I'm just going to go ahead and say that it's, let's say 18 mil MRMDF. Now that job name already exists, so I'm just going to say alignment to, so I can walk you through the steps. So with that selected, let's go ahead and add in that material. All right, now you can go through and measure the actual piece of material that you have and set the width and length. And for your machine, you might need to do that just based on the overall like vacuum table. So I'm just going to take a quick check of that just to get a rough idea. So we're at around about 230 mil that way, and coming off this way, around 1200. So that's going to be close enough for what I need for this example. So we're going to go 1200 there, and we're going to go about 230 here. Now, for our trim, I'm actually going to just zero this out, and I'm not going to do any trims in this example here. So I'm going to go 0 there and 0 there, because I'm not actually going to cut this out. I'm just going to do a square, and I'll explain that as I go. So let's go ahead to parts now, and we're going to add in a new part, and I'm just going to make my component, let's say, actually what I'm going to do here is I'm going to make my component 100 by 100. Let's do this slightly different. There's a couple of ways we can go about this. I think what I'll do is just make the square 200 by 200 just for simplicity. And we're going to go into edit part operations. So what I want to do here is make sure that I'm going to drill a hole, right? And as I mentioned there previously in the video, I'm going to want to set that a set distance in off the edge of that material. Now, because I've got no trim, I know that my part's going to be hard against that edge. So I'm going to just say, allow it to be 100 by 100 in off that edge. And I don't really need to go that deep. I'm just going to go a 10 millimeter hole, and making sure you pick a diameter that your machine has. And I'm going to go with a 5 millimeter diameter here. Now, I don't want to cut the part out. I'm actually going to not send that to the machine just to avoid, like, I've got a really small component on there. I don't want it to move. So what I'm going to do instead is create a toolpath. Now I'm going to go at close toolpath and press OK. And now this toolpath is where I'm going to control how far in off the edge it is to that toolpath. Now, right now it's 50 millimeters in off the edge. It's 50 millimeters in off the edge that way. And the overall length of this is 100 millimeters. So I've got a 100 by 100 square. That is 50 millimeters in off the edge. Now, what I can do there is go ahead and set a depth. Now I don't need to go all the way through. I've got a 10 millimeter compression bit on there that's got about a, let's say a 7 millimeter of upcut. So what we're going to do there is just set this to say 7 millimeters in depth, just to make sure I'm going down deep enough. I might even go to 8 millimeters, just deep enough to make sure that I'm getting the down part of the compression and therefore keeping it nice and clean. For selecting the tool, I'm going to go ahead and select the tool for this machine, which is going to be the 10 comp. And now keep in mind that this is a centerline route, right? Which means it's actually going to be 45 millimeters in off the edge both ways, assuming that tool is exactly 10 millimeters. So what I might do there is just offset this path in by like 5 millimeters. So let's go -5 and OK. And what that's done there is that's moved the edges in 55 millimeters, assuming my diameter is exactly 10 mil. And this is also a good way to check, because I can measure the trench that it leaves behind with some verniers or calipers to make sure that it is actually 10 mil. Another key point of, testing alignment of things. So now I've got if I just show you this in 3D, I've got this little component here. I'll just make that full screen. So this piece is going to be hard against the edge of the machine, against the reference pins. it's going to do a route that should lead me exactly a 50 millimeter border in the x-axis and exactly a 50 millimeter border in the y-axis. It should drill a hole exactly 100 millimeters off the edge in the y-axis and exactly 100 millimeters off the edge in the x-axis. And that hole should land exactly in the middle of those routes. If that is all true, then I know that I'm dialed in and ready to do foot sheet machining. So let's go ahead and progress to the next step. So we'll go okay there, and we're going to go to optimize, and we're going to go ahead and optimize that. And obviously we've got batch turned on, so it'll ask me which material. So there it is. There's my piece. There's my part. And as you can see, I've got the trims turned off because I don't want any extra tolerance there. I just want to make sure that part's hard against. I'm not going to cut the part, right? So when I G-code this, I'm going to press generate G-code, calculate. I'm actually not going to do the cutout. So I'm going to just delete that path. So it's not going to do that cutout component. All it's going to do is drill the hole and then do the manual cutout that I made, right? So by coming in and adjusting your toolpaths there, you can just remove the cutout, and then, it keeps it a much more accurate way of representing if everything's in alignment. So next step there. So the next step there would be to go to G-code and okay, and then we're going to export the G-code for this one. Depending on your machine, you might have this networked and can send it straight there. You might be putting that on a USB. That all comes down to your workflow, but I've got this network, so it makes it easy for me just to generate the G-code straight in the location where I can pick it up on the machine. So now we're ready to run the alignment test. All right, so we've run our first alignment test. As you can see, it's moved on the machine. So, we're using quite a small component, and the pressure of the tool coming down has just shifted that. So definitely a really key thing when you're running an alignment test is make sure you pick an offcut that's big enough where it's not going to move and you're not going to have any inconsistencies there. So a hole will be fine to measure off this one, but we can definitely not trust the router because, as you can see, it's sort of dipped in and shifted as we cut it. So we're going to pick a bigger piece now and run that same alignment test again. So definitely a good real world example of what not to do. Don't skimp out and just try and get the smallest offcut you can when running an alignment test. So Anokin's going to load on a much bigger piece of material now, which will have more accuracy in making sure that ain't going to move. So let's bring up the pins and
Crossed anyway.
take two. All right, so now we've got a much cleaner cut. The hole's been drilled and the route hasn't moved, so I can see it's all nice and true. So let's just check against the tape to see how we're looking. I've got a real man's tape measure here, so everything's in metric. None of that imperial nonsense. Sorry, all you guys in the States. So first of all, working off the edge, it's fractionally under 50 millimeters there. If I work off the 100, income across, just to get a more accurate reading. The tape's pretty accurate, actually. It's still slightly under 50. So let's check what we're doing in this direction. Anyway, we're probably just almost bang on the 50, or if anything, marginally over the 50. So tiniest bit of variance between the two in the x-axis and y-axis that way. And coming and looking at the hole. So I'm sort of seeing the same thing here, that it looks like it's slightly under the 100. So it's not much in it, but it's probably less than half a millimeter, maybe 0.25 of a millimeter in this way. So if I was to put a measurement on it, I'd probably say 99.75 off the edge this way. And then coming back this way, let's have a look. I'd say I'm almost bang on the 100 that way. So more accurate. I'm going to have to just spin this around so I can get a closer reading myself. Anything slightly under as well. What I might do to visually demonstrate this is just draw exactly where the 100 mil is, just so you can see the difference. All right, so let me show you what I mean here. So measuring in off the 100. And then let's go back this direction. So, Anakin, do you want to come take a look at this? Make sure I'm not crazy. As you can see, it looks like it's slightly off center. What do you reckon when you look at that?
Yeah, like very minuscule. But yeah, there's a slight variation there. Like you said, point of a mil.
So I'd say like what we're looking at here is this is the y-axis running in this direction. And we're saying we're about like 99.75, something like that, to the center of the hole. And then what we've got here is our x-axis running in this direction. And we're roughly the same. So we're pretty even, but we are, yeah, look, it's just a fraction out. So, I would like to, probably look at shifting this slightly just to make sure we're bang on, getting the hole to shift that way slightly and this way slightly. And then looking at the route, and it's again, you're getting pretty accurate. It's hard with a tape. You may want to get like some verniers just to check this more accurate. And here's one I prepared earlier. Here's one that Anakin's prepared earlier. So we'll just zero that off. And what we can do this way is we can actually put them and get a measurement that way. So, I mean, 49.95 is pretty good. We're within 0.5, 0.5 microns of a millimeter. So, pretty damn right. And then, yeah, we're bang on like 50 there, or if anything, 49.9-ish. So pretty accurate for the router. It's really the drill that's probably the main concern. I mean, you can probably try and do it this way as well, of like getting a measurement, so 97.5 to the edge of the hole. And if you add 2.5 millimeters, should be exactly 100, right? So, I mean, we're pretty close. Maybe the tape's like slightly out. What we're trying to make
It's been a battered tape as well.
Yeah, I mean, and we're 97.5 that way again. So the other thing you can try and do is just check if the hole is equal to your part as well. So 37.86 that way, and then coming in here, 37.83 this way. So like is really the good thing here is what I'm seeing is that the hole is pretty much like accurate according to the X and Y. You can check it this way as well. Like you could go from this side, and what you're seeing there is you're like 37.79, and then off this edge of the hole to this one, 37.5. So that's like kind of aligning with what I said, that it's like it needs to move this way by about 0.25 of a millimeter. So again, 37.8, sorry, and then this way 37.55. So there is roughly that 0.25 of a millimeter discrepancy with the hole, which, right, what that means at the moment, if I'm happy with that, it is going to compound. So that like that 0.25 of a difference when I flip the sheet over is going to be 0.25 again on the other side. So, I'm going to end up with about a 0.5 millimeter difference between my hole and my routes when I look at the hinge locations. And that seems to be consistent in X and Y, right? So, you imagine you're cutting your door, you've got your hinge hole there that's only like 3 millimeters in off the edge. Well, that might turn into 3.5, or it might turn into 2.5, depending on which way you go. And ideally you want to get that note to be correct. So the next sort of part of the process or piece of the puzzle would be on your machine, understanding how to adjust the references of the drills and getting them to move the right way in X and Y, and running that test again to make sure that then we're bang on in that direction. So really good test to do from the perspective of just understanding, is your hole exactly in the center of your routes, and are they the correct distances off the edge? I'm happy with the distances off the edge when it comes to the routing, so that's good. I know I don't need to adjust my routing references, but the drill bank reference, it would be good to just tweak that by that 0.25. So let's take a look at that. Okay, so on every machine, this is going to be a little bit different as to where you adjust this. On the majority of machines, I'd say you're going to probably find like one global origin setting that you can adjust. This is an older model machine, so what we're finding is that the adjustment is actually made across the board on each of the individual drills. So there's no like sort of one global setting where I can adjust all the drills at once and their distance from that router bit. Right, so what we're getting instead here is if I open up, say, T1 and I right click and I go information on item. Now, keep in mind, I need to enter a password to get me into this because this area is kind of password protected. So some of the screens might be grayed out. When you're looking at them, I'd recommend like reaching out to your machine provider, making sure that, you know, you've got access to be able to do this kind of thing. Or at least have someone talk you through it. Now, what we can see here, our X offset, right? So our X offset there is at minus 0.1, and then our y offset is at minus 0.05. Okay, now what I'll do is just go across to the second one just so you can see this. And if I open up the information on this one, well, this is at 31.9. So when this was done originally, I would say somebody ran this test, they figured out that, you know, maybe it needed to shift 0.1 this way. So then they went through and adjusted each of these individual items by that 0.1 on the x-axis. So you can see again, instead of 64, it's at 63.9. I guess what we want to do now is compensate because we actually want to go, and this is where it gets a little bit tricky, is knowing which direction. Do we want to make that like 64.15 or do we want to make it, you know, take 0.25 off that? That's always tricky to know because it gets really complicated based on like, is your machine moving in a positive direction, negative direction? I would always say just pro tip would be, you know, open this up before you make any changes, just whip out your phone and take a photo of that, you know. So I'm just going to go across here. I'm going to take a photo of that. I've got a photo that I can reference back to. Okay, so that's really key. Just make sure, you know, before you make any changes, you just document what it is and then you can go from there. So I'm going to assume or hope that it's T1. We're going to run the test and see if anything changes. So I'm going to go, instead of minus 0.1, let's change that to a 0.15. So I'm adding 0.25 mil to the X offset, and I want to do the same to the Y offset. So it's at minus 0.05. So I'm going to change that to a positive 0.2. So 0.2 is what I'm going to shift that to. So hopefully what I've just achieved is shifting the origins of this drill by the 0.25 in both the X and the Y direction. And then I'm going to rerun the test and make sure that that's worked. If that's worked, then I'm going to go through and make that same adjustment on each of my drills. Now, just as I mentioned there, you know, hopefully on your machine, you only need to change one global origin, but on some machines, it will be an individual origin on every single drill. So just keep that in mind. You really need to check how it is for your machine and then follow the steps. So, you know, hopefully you've got a great machine tech that represents the brand of machine you use that you could reach out to and ask them, hey, if I wanted to adjust the alignment of my drill to the router, how would I go about doing that? But let's go ahead now and save that change, and then we'll go in and run that test again and go from there. All right, so let's take a look at how we're looking now. So that looks better. I'm getting that like bang on 100. And looks like I'm good that way as well. Just double check. Yep, that's looking good. Yeah, we're pretty much bang on there as well. And it's coming back this way. $37.5. 37.5. And I'll do the same this way. $37.54. Maybe put it 37 point. 4, 5. So yeah, we're basically dead on, which is good. I mean, it depends how accurate you want to be, and you've got tolerances and just, that where you're picking up that pinch point alone, so you don't really want to probably need to be any more accurate than that. But the main goal of the objective here is to make sure that your borders and your hole, your holes in the middle of your part, your borders are equal and consistent. That way, when we flip the sheet over, you're not shifting that hole by like, a millimeter or 2 millimeters. Like, because when your hinge hole is only 3 millimeters in from the edge, shifting by like 2 millimeters can mean the hinge hole ends up like 1 millimeter in from the edge, and you might not have enough adjustment in your door then to account for that. So the whole objective is to make sure that you're, accurate enough, and I want to be like kind of less than 0.5 mil in my tolerances to make sure that, we're gonna be good when we start doing flip sheets. So let's call that a win with the alignment, and we'll jump on to running a test door to make sure our Zs are all correct for our MDF door tool profile.
Cool. So now that we're at the stage, we've done all the calibration and we've done all that testing for our alignment. The next thing is to actually work on our test door rather. So for this one, I've just gone to my order tab here, and I've just brought in a standard shaker door. We've got my heights all set there. My profile 1 is going to be used for my cutout tool. And then profile 2 is the actual tool set I'll be using to do the inside profile of the door. If I actually go into the product itself, and we go to our parts, and I open this up, and my operations. So we can see here that we've got the shaker in 4 mil. So what this is, the panel tool grip consists of multiple tools. And this is a great feature. That way you don't have to have so many line items of tooling done for one door or one product. So what we've done here is this consists of an 8 mil down spiral and a 22.5 degree V-bit. So that way both tools will work in different orders in order to achieve the final look. So they're set at 4 mil. And then this value here determines the depth of my pocketing tool. Now, I've just selected to use pocket tool, and what's so great about the software is that it will actually sift through all the tools in my tool set and identify which ones actually are allocated to do that operation. Now, it will intuitively realize how big the surface space is, and it will pick the most appropriate tool to run that operation. So happy that that is 4 mil. My tool group is also 4 mil, so I can go ahead and have a quick look as well. It doesn't hurt as well. If you want to have a quick look and squeeze at the final product there, if there was a discrepancy between the tool group and the pocketing tool, I'll actually notice it on the inside edge here. There'll be like a little step there. So yeah, hit OK. I know my cut list. Okay. So in here, I'll just pick, I only got the one door anyway. I'll go ahead and optimize that guy there. Just one, there we are, perfect. So what we're going to do is we're going to work off the existing piece that we did for our alignment test, and I'm just going to shift it 200 mil away from the inside, from the outside edge. So I'm going to quickly run my tape measure over, make sure I have the piece accurate. Check twice, cut once, as you like to say. So I've got about 12, let's say 1210 there. And here I've got 422. Sorry, see, check twice. Yeah, 422. But I had 412 for example. So I'll change those values. So I'll go 1210 and 422 on my width. Okay. So I'll go to my parts, check my parts are all there, just the one part. And then I'll go to the optimization, okay? So go ahead and do that. And there we are there. So as I said previously, so we've got it set in our 00 origin there. So all I'm going to do is just simply can right click on that, and then I can change the X position there. So I will just move it by 200 and hit enter to ensure I've got perfect clearance away from all the previous operations we've done on the part. Okay, I'll generate my G code. All right, so kind of walking through the steps here. So the first thing, and it does it from top down. So the first thing that the CNC is going to do is run the pocketing operation. So once that's done and completed, it will go ahead and do my 8mm down spiral on the inside edge. So it's obviously being a 40, this hogging tool in this CNC is 40mm diameter. So it's going to leave like a 20mm radius scallop on the inside edge of my door. So that's what we use the 8mm down spiral. It will go in and clean them those corners. So it's essentially leaving only a 4mm radius in those corners. So what we do from there is that's why we have our 22.5 degree V-bit, and that is actually going to go in and clean out those corners. And what's great about it as well, it's going to ramp in and out of those corners at the same trajectory angle of the bit itself. So it ensures that it gives you a nice clean square corner there. And lastly, it's going to do our cutout. So it's going to go around with a compression cutter and finish all that off. So once you're happy with all that, you can go ahead and hit the G code. Generate the file. And we'll send it off to the CNC to get cut right now.
So that's awesome. Like, what main thing I'm looking for here is that there's no step at all between the 40mm hog and the 8mm down. Like, that's dead perfect. You don't have to sand that. So that's the goal. Like, you know, and
Tana's happy.
And we're using a PCD diamond hog. So, I mean, that is, yeah, just smooth as, like, keep your sanders and painters happy, right?
Yeah, for sure.
But, yeah, that's nice. And then the 22.5 as well is not going, like, it's not going too deep, like a little bit of fur in there. But I mean, that is just, it comes down to the quality of the machine grade board as well.
It's not machine grade. This one's just standard white side and 18mm.
Yeah. So once you got like the machine grade stuff, that should be a little bit cleaner again. Otherwise, yeah, we're good. So, I mean, at this stage, you know, we've run our alignment test. We know we've got our drilling and our routing dialed into our stops. We know we've got the depths of our tools all aligned. So at this stage, we're at a point where I'm comfortable to start running shaker doors and flip sheets. So let's get into now, like, looking at how that works on a whole sheet, understanding how far to come in, the trims and everything like that. So we'll get set up for that and we'll go from there. Perfect. So that'd be your 2 sheets of 21, and then that's your third down there.
I believe so. Yeah. That's right. Yeah.
Okay.
Yep.
All right. So we've got our top 2 sheets of 21 here and one further down in the pack. So first thing we want to do is just measure the overall sheet size. So measuring this way, we're sitting at around about 12, 13. You know, you're looking also visually to see, like, you know, how much of a, is there any damage on the sheet where you might want to increase your tolerances. It looks pretty clean overall. And you really want to get a pretty, you know, good idea of what that is. So yeah, say 1212 millimeters would be the correct size that way. We're on the tape this way. And you're at 2419, so just under 2420. Now, I mean, the main goal here is obviously your sheet's not going to be square, right? And to do a flip side machine where we're turning the entire thing over, it really does rely on squaring off 2 edges where an edge this way and an edge that way can be square and true according to the machine. So looking at this machine, right? Your stops are in this back corner.
Yep.
Okay, so what we're going to do when we push the sheet on, we want to be trimming this edge at the front and the edge down against the reference here along that back edge.
Yep.
Because the goal is to be able to have everything off that trimmed edge this way and that trimmed edge that way, and then we're going to roll the sheet over on itself. Very, very hard. Like if I'm a one person, right, doing this is 21 mil thick MDF, so it's pretty heavy, right? But I can lift it this way and I can flip it over that way. What will be really hard is flicking it that way, okay? Because I'm going to get to a point where I'm probably going to hit the roof, pendulum swing. So first question everyone asks is like, which way do I flip it? Well, unless you're Hulk Hogan, the only way you can, which is over on itself this way. So thinking about where your trims are, where your stops are, it's always the edge you want to trim in Mozaik, and we'll show you this as we get it teed up, is always the opposite to that. So we're going to trim the front and that left side. Now, how much by is the next question. Well, you know, it depends on a few things. Like the sheet size was 12-12 this way, right? That's the kind of critical one. We don't want to overinflate that number. If anything, we want to kind of go slightly conservative there. So I might go like 12-10 just to make sure, you know, if anywhere along that sheet, I'm not going over what it is. If anything, the other one was 24-19 or 24-20. I want to make sure that when my tool comes through to clean up this outside edge, it goes far enough past the sheet to not leave like a little indentation there. Because if you, especially if you have a machine where it's a full bar across the back, any trim that doesn't clean it all the way through is going to hit that bar and then push it off the sheet by the trim amount. So if anything, when you put in your length in Mozaik, I would say whatever it is plus like the radius of the tool. So, you know, I'm going to go 24, 25 in my overall length to make sure that I'm got my trim cut going through far enough. But on the width, I'm going to go a little bit under. So I'm going to keep that at 24-10. And then what we'll do just to visually kind of explain it too is with the trims, keep it nice and easy to understand. So I'm going to go like a 10 millimeter overall trim, which means that we're allowing 10 mil of any discrepancies of tolerances in the sheet size and, you know, any like kind of damage where you might have hit it with a fork along in the material. We're allowing 10 mil overall, which would be more than enough in this case. And it's 10 mil overall and 5 mil each side of the sheet. So 5 mil on the first cut, 5 mil on the second cut. And that's what I want to visually explain by maybe getting a straight edge and just drawing a 10 mil line across this and then a 10 mil line across this trim side. And you'll see then when we run the first side of the sheet, it's going to cut half of that away and half of that away. So taking 5 and 5. Yeah, and then it makes sense then when you see the measurements in Mozaik for the width trim, length trim, and also for the squaring cuts, it'll make sense. So let's do that next.
Sounds good.
Cool. So you want to jump on that side? Well, I'll throw you the tape. We'll just measure out the trim because I just want to illustrate this to make it as graphical as possible. So I'm just going to measure in off the edge and just mark out my 10 mil. Cool. Just hold that on the 10. Yep. And then just we'll draw that line in. Thank you. Sweet. All right. So this is going to give us a good graphical representation of what that is. And we're going to do the same thing on the short side here. So we'll just grab that tape again. So let me bring you guys in a bit closer here. So what we've done here is just drawn a 10 mil line in from the edge. I just want to represent what the overall width trim is going to be all the way around. So again, we're 10 mil in on both sides here. And what we're gonna set our width trim and our length trim in Mozaik to that 10 mil value. That's what's gonna be the overall allowance of how far we're stepping in. On the first cut, on the squaring cut, we're gonna set that to half of this amount, right? So we're gonna set it to 5 mil. So what you'll see when we run the program is it's only gonna be taking half of that trim away, so 5 millimeters, and then 5 millimeters this way. And then when you flip the sheet over, it should basically cut the doors up to that line. So that's the overall 10 mil. Think of that width trim and length trim in Mozaik as the position that the actual finished parts are going to come out from. And think of your squaring cut as half of that amount, as the first square off cut, because what it should give us is a nice square true edge, and then everything is drilled and routed true to that squared off sheet. And again, the trims are going to be opposite corners to where our pins are. So looking at the machine, our pins are along this back edge of the sheet, and then along this edge here, and that's where we push the sheet to. And so what we're going to do is we're going to trim along this edge and then along the front edge. And that's the bit that confuses a lot of people, is why is it the front edge? Well, it's because after I drill my holes on one side or whatever's on the first side of the flip, it's then going to be rolled over, and that square edge that's along here is then going to sit back against the pins, and then everything will be nice and squaring true. So let's go ahead and switch over to Mozaik now and see how we get this all set up with the correct settings to get this dialed in.
Cool. All right. So thanks to the measuring that Dave did, you can see here when we open up, by default, it's got, like, for my material list, that my default size is 2410 by 1210. But being this is in a flip sheet operation, we want to make sure it's spot on, just to echo Dave's words, right? So Dave, would you mind relaying the information?
Yeah, so 2425. So we wanted to go that little bit longer on the sheet size to make sure that our trim cut goes far enough along that we don't end up with a little mark on the end where the tool hasn't gone far enough past.
Yep.
And then on our width, we're going to go 2410, which is actually what it was already. So, sorry, 1210. Sorry,
I was going to say.
on our width, which is what it was already set to. As we measured 1212, so I would just say you want to just be a little bit conservative and just go slightly under. You don't want to be over. So 1210 is more than fine when it comes to the width. And then here's your trim. So you've got your width trim and your length trim. And as I mentioned previously, we're going to set that to 10 mil just to make sure that we're allowing enough tolerance. I mean, once you've done a bit of this, you might try and reduce that. You might come down to like 6 mil and 3 mil. But I think at this stage, let's keep it really clear and obvious and go 10 and 10. And then we'll go ahead and optimize this.
Cool.
So here on the optimizer screen, we're going to do two things. We're going to say sequence flip side parts first. What that's going to do is basically just mean that if you've got a whole job, it's going to try and take any part that needs flip in and put it on the first sheet or the first X number of sheets, whatever it needs. So rather than scattering the flipped components over the entire project, you'll end up with a few sheets that need flipping, and then the rest of the project won't need flipping. Otherwise, you'll end up with like one door here, and then one door on like sheet number 5, and one door on sheet number 10, and then you end up just flipping more sheets than you need to. So definitely a key one to turn on. Automatic flip parts will also leave turned on. In this case, we've only got the one material, so we can uncheck batch optimize, and large parts first is also fine. It's not really going to make a difference for what we're talking about here. So cool. Let's go ahead and press optimize there and take this through. So we've got 3 sheets of material. Let's take a look at pattern number 1. And what we'll do is we'll just visually show you here first. So we're going to go generate G-code and calculate. So what we're seeing here is this is the sort of second part of this program. So we've got our 40 PCD, we've got our 8 router, our V22, and our overall cutout. So this is all what's going to happen secondary once it's already been flipped. But you click flip sheet there, it will pop up with this option. Now, this is what I was talking about with a squaring cut. So we're going to tick on the option for add squaring cut. And our trim amount here, the real key piece of information in this entire video is making sure your trim is 50% of whatever your width and length trim was at the earlier step. So as you saw, we had 10 mil previously. So we're going to set this to 5. And that's going to make sure that it's taking half of that away on the squaring cut. And then the other half when it's repositioning the actual cutout of the doors on the second part of that program. And then, as you can see, you're presented with the 4 choices. And of course, that's going to be different according to your machine. But as we can see visually here, and I might just borrow this camera and sort of visually show you this. So we're going to go with this option here, number 1, because you can see where the red line is. It's along the side of the sheet and along, so looking at the sheets, along this side and along the front. And in looking at the machine, that makes sense because our stops are across the back and our stops are across the side. And so when we roll the sheet over, it's going to end up being all trimmed. So that looks good. So what we'll do now, rather than, and just press OK there, because what we will show you here is now we can see is as we're clicking through this interface, we've got the 10mm drill, the 35mm drill, and then that 10 comp, and we'll just press simulate there and you'll see this. It's doing the squaring cut along that left edge and along that front edge. And so that's where it's going to, trim that 5mm away and square off the sheet. And then obviously the holes are for the hinge drilling. Looks like you've got a 10mm drill.
That's Salichi.
Salichi. Yep. Okay, cool. Sweet. All right. So jump out of there, just press X, and then we'll go view all patterns because we can export all of them at once now. So we're going to press generate G code. And yeah, we're going to do all the sheets, and we're going to come down to the second last checkbox there and generate flip sheets. So what we showed you a second ago was, that step's not really necessary when you're doing a full job. That was just to visually see it a little bit clearer, but you can do all the patterns at once. So by looking at all the patterns and clicking generate G code and then clicking create flip sheet programs, you'll get the same prompt. So we're going to tick on the squaring cut. It will remember your previous settings once you've got save as default, which means that, our trim cut set to 5, and once you've got, the choice of the 4 different trim corners on for your machine, you'll never need to change that. So you can default that. So press OK. And then there you go. We've exported. All right. So for those of you that don't have an onload or offload or an automatic labeling machine, then you're fine to leave the files as separate. So we're going to show you here an example of them being separate, where you're going to have the same program name. So you can see here that our program name is like S01, R02, and one of them has an F, and one of them doesn't have the F. So the F, whether you think it stands called clip or first, doesn't really matter, but you can take that as an indication that that is the one that you should run first, as that one will have the squaring cut. So we're going to start with that one, get everything teed up on the machine, and see if we can film this getting cut. Well, let's take a closer look. The line that we trimmed, so was 10mm, as you can see, we're a little bit under the 5mm remaining. Now the reason for that is we allowed less on the actual trim, right? We said the sheet was only 1210 just to give ourselves a bit more tolerance. But the important thing is that these holes are the correct distance off the pin for the hole, and the trim is the correct distance off the pins to here. So that's the most important aspect of this. And as you can see, this is why I wanted to run the sheet length a little bit more, is just to make sure that my cut exceeds where my sheet's gonna, and that you're gonna get a nice clean edge there. And then that way I can roll this over now and put it back against the pins. So everything's on track there. As you can see, once I take that extra 5mm away on the second cut, that hinge cup going to be in the perfect location. So let's get this set up to flip it over. Right, so there we have it. Let's take a look at the other side. As we can see, got a perfect hinge location, 3mm in from the edge, and that is all dialed in, ready to go. We can even run a tape over it and check our hinge locations, make sure they're all good, but otherwise, that is a perfect flip sheet shaker door, straight out of Mozaik. Minimal fuss.